it a couple of days later. So let's get into it. We're talking from lesson 1. So far in this, we have reasoned abstractly and quantitatively. We've constructed viable arguments and critiqued the reasoning of others. We're going to continue to do that on page 209. Get that up there for you. Have something to write with. Have a protractor. It'd be amazing if you had a compass, something, like this. And then, of course, some highlighters. Within a circle, an interesting relationship exists between the measure of a central angle and the measure of any inscribed angle that intercepts the same arc of the circle. Vicky, whoever this person is, conjectured that the measure of an inscribed angle is equal to the measure of a central angle when both angles intercept the same arc. You should probably go back through, like I am, and highlight some of that vocabulary so that you see it, or if you didn't read anything along the way, you are now. Inscribed angle. We need to make sure that we find that and use it. And different highlight color because it's going to be represented here in the picture, the central angle. And then it'd be fantastic if you had a third highlight color. I don't have any close to me, but I will probably for the next video. Stick around for that one. Let's draw a central angle. Central angle is created by drawing from the center out. And drawing from the center out. All right, there it is. There's my central angle. And I drew these lines longer because I'm thinking ahead. Probably I don't really need them to be drawn that long, beyond the edge of the circle, but we should measure them, okay? Which, by the way, also, this is a central angle. Highlight it to match the central angle vocabulary. Central angle, central angle. Okay. Measure the angle. I mean, if Vicky said that they're going to be, that they're the same, right? Equal, I should read it again. Vicky conjectured, okay, that means made up a rule, that the measure of an inscribed angle is equal. We're looking for equality between this angle and the inscribed. So we'll do this in a couple of stages. I'm going to measure the central angle. Protractor, you put the center circle of the protractor on A. And then this black line of the protractor, you line it up with your pencil mark. And then out here along the edge of the protractor, we're going to look for what, what degree mark that it crosses. So starting 0, 10, 20, 30, 40, 50, the line is between 40 and 45. So 40, 43 it looks like, okay? All right, we have a 43-degree central angle. Yours might be different. Mine was a 43-degree angle. You need to make your own. Now let's do the inscribed angle. And to be inscribed just means that the angle is completely captured on the edges of the circle. So, I don't know, maybe like right here. This is totally random, by the way. It could be at any location around the major arc of the circle, but it probably makes a lot of sense to put it somewhat on the back end of this angle, this pink one. And then where the central angle, this arc that's created right here, we're going to connect this random location on the circle to both of these markings. So here, again, like I said, there's probably a smart place to put it because the overlap that happens here is all you created, like you made the mistake. You can choose a smarter location. I could have chosen a smarter location, but this will at least do the job well enough. Okay, the goal. Measure that angle. We're going to compare. These should both be 43-degree angles if Vicky is right. Okay, once again, the circle of the center of the protractor goes on the angle's vertex. And then the black line, the 0 line of the protractor is going to go along one of the rays of the angle that's created. Line it up, be precise, and then it looks like, oh, I used the same line, in fact, more or less. 23 degrees, maybe a little under 23, like 22 degrees. Okay, so first of all, they're not equal, right? So, no, I disagree. But I disagree because I have my evidence right here. The central angle, I'm going to use some semi-correct geometry notation. I get a central angle of, I think I measured a little bit wrong. I think it was actually 44. Go back and check the tape. It was a 44-degree angle. And then the inscribed angle, measure of angle inscribed, is 22. So bring in some highlight. The measure of the central angle is 44. The measure of the inscribed angle is 22. And for that reason, Vicky is wrong. But in the moment, let's think about it for a second. Do you see a relationship between those two angle measures? I made them up randomly, right? I just drew an angle. Do you see a relationship between them? Is it possible that a different relationship than equal can be used? Maybe double or half? Certainly not equal, though. Okay, let's continue on. Let's get this page knocked out, finish this portion of the videos for our lessons, and then get you ready to go on to the next page. Consider the measures of the inscribed angles that intercept the same arc. Forgive me for adjusting the camera while you are watching this and I'm creating this. Okay? Professional video maker right here. That's not true. Professional teacher. Okay, consider the measures of the inscribed angles that intercept the same arc. What conjecture can you make about this relationship? Okay, you're going to be Vicky, like, you know, the previous question, but you got to be right. So it says use points W, X, Y, and Z to draw examples to explain your reasoning. Once again, if you're not reading the sentence frame, that's on you. You got to do that. So to match the information from up above, let's go yellow for inscribed angles. Highlight the vocabulary. What conjectures can you make about this relationship? Well, what relationship? Inscribed angles? I guess we better draw some inscribed angles. They don't go from the center. They go, what's going to be easiest? Let's do the inscribed angle along YZ. No, I'm just picking that arc, the YZ arc. Notation. I'm picking the YZ arc because I think it's going to be like open enough for our giant protractors to actually work. But to create an inscribed angle, then I'm going to go from W through Z. So please draw that as well. And then W through Y. There you have it. This is the measure of angle ZWY. And I need to figure out how many degrees that is. So let's go ahead and use the protractor and measure it. Okay. Set the center circle of the protractor on W. I line up the black line of the protractor with one of my rays of the angle, arrow. And then along the other line of the protractor, I'm looking at 10, 20, 30, 40, 50, 60, 70, 70, 71 degrees. Right on, right on. Okay. Now I'm going to make the conjecture up before I actually show my example. I think they're equal. If they're both using the same arc, right? Here's what I mean. I'm going to draw this one in. So draw in X, Y, and draw in XZ, ray XZ. I think both of those angles are equal. You might even be able to say yeah, look, they look pretty similar. We could even get tracing paper and trace it and copy the tracing just to show look, the trace of one matches the trace of the other. That's totally fine. But we have a protractor. We're intelligent people. We can do this. Center circle. By the way, I said they're equal, right? Inscribed angles on the same arc are going to be equal. So center of the protractor, black line of the protractor should line on top of the arrow. And then you look at the other arrow of that angle, 10, 20, 30, 40, 50, 60, 70. I'm starting from 0, right? You got that? I'm not starting from 180, 170, 160. I'm starting from the inside, 10, 20, 30. Then I go 60, 70. Oh, it's 71 as well. The measure of angle ZXY also equals 71 degrees. You know what that means? I'm just going to say it for all of them. All, what's the best way to say this? Not all. It's for this arc. Inscribed angles. There's probably a chance for you to pause the video and make up your own rule and see if it matches mine, and then you get the credit, not me. Inscribed angles that are created with the same arcs are congruent. There's my statement. That's page 209. Thanks for watching this video. See you on the next one.